Hi everyone, my name is Bourget. I live in Montreal, Canada, where I work as an independent management consultant. I'm going to talk to you about the situation in the greater Montreal area. Located at 45 degrees latitude north, Montreal is an island city. 2 million people live on the island and close to 4 million in the greater Montreal area. I live on the smaller island marked with a red dot on the picture you're looking at now. Montreal is a francophone city. English is also largely spoken. 80 languages are spoken in Montreal. Most people are bilingual and many trilingual. This multicultural environment fuels a diversified industrial and commercial base, including a dynamic education sector. Montreal has 4 large universities, 2 francophones and 2 anglophones, and close to 450 research centers. Private houses and small buildings are mostly made of wood covered with bricks. Public buildings and high-rises are mostly made of concrete or cement. Montreal's climate is characterized by a major seasonal amplitude. Temperatures varies from an average of January low of -10 degrees Celsius to a July high of 20 degrees. Monthly precipitations vary from 60 to 90 millimeters, either rain or snow. As for climate change predictions, we are fortunate to have detailed predictions for southern Quebec, which includes Montreal. They are based on the models of the Coupled Model Intercomparison Project, the CMI P5 models, and were developed by Uranos, a research consortium grouping universities, government, and private corporations. This graph presents temperature predictions for representative concentration scenarios 4.5 and 8.5. As shown, by 2080, a minimum increase of 2.1 degrees Celsius with RCP 4.5 and a maximum increase of 7.2 degrees with RCP 8.5 are predicted. A significant increase of temperature is therefore unavoidable. This will result in an extension of planting season by as much as 30 days in 2050 with RCP 8.5. It may also result in a dramatic shortening of the snow cover period to 20 days in 2100, as compared to approximately 120 days today, as shown on this map with RCP 8.5. As for precipitation, the trend observed is a net increase, here pictured for RCP 4.5 and RCP 8.5. This map shows the increase for the region with RCP 8.5 in 2100. It's dramatic. The table presented here also shows various other predictions of interest. A displacement of rainfalls is projected with an increase that could reach 27% in winter and 18% in spring with RCP 8.5. This will have a major impact on the environment. It is also expected there will be a significant increase in frequency and intensity of heavy rainfall events, up to 25% by 2100, according to the same scenarios. The growing season might increase by as much as 30 days, as we said, with a related increase of 600 growing degree days per year, which is enormous. Finally, heating degree days might decrease markedly, as seen on the table, whereas cooling degree days might increase but by a smaller margin, resulting in an important net energy saving. The impacts of these changes have been analyzed by the City of Montreal. I summarize in this graph the relative importance of the resulting phenomena, color-coded. Red means major impact, of course, and yellow minor impact. As you see, by far, the most important impacts are linked to heavy rains, destructive storms, and floods. Those impacts have been analyzed for various issues that I grouped here in 3 categories: health, infrastructures, and a general category. Health-related issues are many, as you may see from the list that is projected now, but all in all, they are highly manageable. For instance, there were 141 cases of Lyme disease and 32 cases of Nile fever in 2013. Even major increases are really manageable. Montreal healthcare system has a really good adaptive capacity. The same comment applies for the following general impacts listed on the list here. Some consequences, but of course, very manageable. By far, the most significant impacts are to be on public infrastructure and private property as a result of increase in heavy rains, floods, and extreme events. We will look at those in more detail as well as at past extreme events of interest from now on. First, heavy rainfalls. We are bound to face an increasing number of these. In the past, some paralyzed the city. For instance, on July 14, 1987, 100 millimeters of rain fell on Montreal in 2 hours. The sanitary and storm sewer network does not have the capacity to handle the sudden inflows of that magnitude. This resulted in flooding of roads and buildings and damages to the sewer infrastructure itself. Also, contaminated water goes untreated because of these overflows. This issue has transboundary health-related ramifications as cities downstream use the St. Lawrence water as their source of drinking water. Floods are also a big threat, but not from the sea. Montreal is a minimum of 8 meters above sea level and 250 kilometers from the current tidal zone. But Montreal is an island city around which passes the water collected in a watershed that includes all the Great Lakes and a large portion of northern territories. We're talking of roughly 1 million square kilometers, or 4 times the size of the UK. Any change in the balance of snow and rain, in its timing and volume, may have dramatic consequences on the river flows. This is exactly what happened as lately as May 2017. Unusually large winter snowfalls in the northern portion of the watershed, followed by heavy April rainfalls, created a massive snow meltdown over a short period of time. As a result, water flows doubled compared to normal spring levels. Important floods occurred in the western part of the island where water hits. This situation is discomforting, as a combination of the same factors is exactly what climate models predict for the area in the future. This displacement of water inflows towards spring and winter may also have disastrous consequences on all living organisms of the ecosystem, as well as on commercial navigation on the St. Lawrence. This issue also has interesting transboundary aspects. Water levels are partly managed by hydroelectric companies that operate the dams. Their interests are to keep water level as high as possible upstream while preserving their infrastructure, irrespective of downstream consequences. A similar transborder issue exists with respect to the Great Lakes. Their water level is jointly managed by a Canada-US Scientific Commission as the border passes in the middle of the lakes. This year, as one of the lake's level was reaching a point where it damaged the US shoreline, a US state governor officially requested that more water be released through regulating dams at a time where Montreal, downstream, was already facing and struggling with floods. The Commission rejected this request. One can imagine, however, that similar transborder issues will arise more often in the future. Another impact is the likely increase in extreme storms. I'm not talking about snowstorms here, as they are more considered as sporting events than catastrophes in Montreal. We like to confront big snowstorms. We are well equipped to face them. But we are not well equipped to face big freezing rain or ice storms. In January 1998, such a storm paralyzed Montreal for a week, destroying trees and infrastructures and crippling the electrical network. I was there. It was terrifying. Trees falling down all around, electric wires all over, and then a complete blackout and heating system failure for 5 days at -5 degrees Celsius. The prevalence of freezing ice storms has increased 28% over the past years, and this trend is likely to continue. Finally, a forecasted increase in the number of freezing thawing episodes will weaken roads and transportation infrastructures already stretched by years of under-maintenance. Every time water freezes, it expands 9% compared to its original volume. Cracks and deteriorations ensue. It's an endemic problem in Montreal. Heavy rains, floods, extreme storms, and freezing thawing episodes have major impacts on buildings and infrastructures and lead to massive investment needs. This is indirectly very significant for the health sector. Montreal and governments have limited resources. It's a zero-sum game. If infrastructures are in danger, no doubt that they will divert resources from paying social workers and nurses towards brick, cement, and pavement. These decisions are likely to hit more directly the elderly and the poor. There are positive aspects though. The extension of the agriculture season is likely to allow for a diversification of cultures and increased productivity in the greater Montreal area. Overall then, the most serious impacts are linked to infrastructures and buildings and the important related investment needs. Let's mention finally that these disruptions will lead to a major change in our way of life. Montreal is a typical white Christmas country with winter carnivals, winter sports, exterior ice rinks, and epic snowball fights. All this culture is already seriously challenged by the increasing freezing, thawing episodes. One should not underestimate the psychological impact of playing hockey, our great national outdoor winter game, indoors forever. Thank you for listening.